Good morning, everyone. Welcome to today's presentation. We are so excited to have you guys join us all. Today, I've got two fantastic speakers for you. We've got Seth Nicholson, our Director of Product here at SewerAI, and we've got Eric Sullivan, our Director of Strategic Development and Certified NASCO Trainer. These two have been in the industry for a long time. They're great people to learn from, and I'm super excited about what you are all about to hear today. So without further ado, I will welcome Seth and Eric on the stage, and we'll get things started.
Thank you, Michaela. Appreciate that. So we're going to be discussing the new AI and cloud-based era of asset planning. Real quick, a little bit of background about myself, and Seth will say some words too. I've been in the industry going on about 19 years now. And I've been focused the entire time on CCTV, sewer condition assessment. And as Michaela mentioned, been a PACP, LACP, MACP trainer with NASCO since 2012. And that's actually how I got connected to SewerAI. I met the founders in 2019 prior to going to market. You'll hear a little bit more about our story and our evolution in that process. But I formally joined the company in 2020, actually during COVID, which is right when we met Mr. Seth Nicholson as well. Go ahead.
And it's been a pleasure to work with Eric. I've only been in the industry about a half dozen years since I joined the company. Previously, I was in solid waste. I've worked in the solar industry. But a dozen years ago, before it was cool, I was helping build chatbots and interactive AI to help people with customer support. Really excited to help bring that technology to this space, and really excited to build the products that we're sharing with you today.
So we'll go through our agenda for this session here. We're going to say a little bit more about SewerAI, what we do, who we are. We'll discuss the status quo, or the traditional conventional way that utilities and contractors and civil engineers have gone about inspection, data collection, as well as analysis and assessment, and some of the challenges that they've faced in putting together capital planning programs and making critical decisions about rehab and planning. And then we'll walk you through our story of how our platform became what it is now. And then Seth's going to provide a live demo of our risk and rehab set of tools. And then we'll open it up for Q&A at that point. And along the way, we'll have a little bit of interaction too. We good? So, a little bit of background on SewerAI. As you can see here, we are focused very much so in the US and Canada, and we work with utilities, sewer services contractors, and consulting engineering firms. We work with utilities of large sizes as well as small sizes. City of Houston, Pacific Gas and Electric, Knoxville Utilities, et cetera, are some of those examples, Casey Water. Our platform currently has over 200 million linear feet of pipe data under management stored in it that cities are using for long-term storage and for collaboration amongst different groups of stakeholders. Our AutoCode AI-assisted process, which we'll share a little bit more about, is kind of the flagship offering of SewerAI. And to date, we've completed over 500,000 surveys, including PACP mainline pipe, LACP lateral, and MACP manhole or maintenance hole. We'll say a little bit more in a bit about what that means for the risk and rehab recommendation engine that we built, and how big data and aggregated data can be leveraged inside of it. But we estimate that right now about 150 million people in the US and Canada are impacted by our technologies, right? The ratepayers that these utilities serve. And one thing that we've been very, very proud about in our journey is maintaining a very high level of customer service and a focus on customer success. So that's a 5-star rating. What that also looks like is less than 1 minute response time for folks that need us and reach out to us inside of our platform, which contains, messaging tools. And right now, under half an hour of resolution time for any ticket or issue that's inside the platform. A little bit more context as well with respect to the AutoCode technologies is we're processing over 35 million linear feet a year right now of pipe data. So that's mainline pipe and lateral pipe of varying sizes, primarily 24-inch pipe diameter and under, but all kinds of large diameters too. And right now our average turnaround is under 5 days from when data is uploaded and initiated on the AutoCode process to when it's complete and stakeholders are notified.
Eric, pause there for a second.
Yeah.
So that's a little bit about us and our company. I'd actually be really helpful to us to know who's here today and what brought you here. So I'm actually going to ask a few people just to understand who's in the audience. Maybe I'll start with these gentlemen over here. One of you gentlemen named Jeff. Where do you come from and why did you come out to our talk this morning? Okay, these guys are over at IDEX next door. They're in the similar space. Some of their products are, at least in CCTV. And we were easy to access this morning.
How about you, sir? What had you show up at this conference?
I heard Eric Sullivan was going to play his bass and sing us a song, but no, I'm interested to hear what advancements are coming. Maybe even the estimation of leaks at defects that are identified.
Thanks, Andy.
Thank you. I'm going to get my guys in the back here because you were giving me a hard time. What brings you out this morning?
Sean, City of Tulsa, Sewer Operations Group. And so we're just interested in really the CCTV scoring act portion of it, and then how the rest of your platform will work with our Lucity and our info asset planner and all that. So don't get too technical, just want the basics.
Thanks.
Thanks.
You couldn't hear him.
Yeah.
That was Sean from City of Tulsa saying he's interested in the scoring and how that interacts with their asset management. Maybe one more. Why'd you come out this morning? Javier, can I get you?
So Javier with the Linden County Water District. I oversee maintenance and operations of our collection and water distribution system, and just trying to find an effective way to put information on our collection system. We CCTV thousands and thousands of miles of pipeline, but we don't really have a good place to put that info. And nobody's NASCO certified except myself. So it'd be helpful to have something like this to put that information together.
Thanks, Javier.
Thank you for your expertise, Javier. And that's a perfect tee up, I think, to what our platform does, and including these new tools we're about to share.
Yeah, for sure. I bet you folks did not know this was going to be as interactive as it is so far, right? This is not television. We can see you, which is fun. So let's talk about some things that aren't fun, though, which is the current state or the conventional ways that utilities and engineers and contractors have struggled with the inspection, the data collection, but also the review and the assessment, and then what to do with that data as far as the decision-making process for rehab and asset planning, right? It tends to be time-consuming, whether it's manual data entry in the field in real time or clunky processes for transferring data from thumb drives or data having to be stored on hard drives in non-secure and non-resilient places. But also, Javier touched on it a little bit, just some of the inherent inconsistency that folks have experienced with assessment when you have multiple different individuals with different levels of experience with respect to interpreting the 220 plus condition codes that there are in the NASCO catalog. There's quite a bit of variation and subjectivity in that, and that can create large problems down the line the bigger the data set is, right? And the use of different contractors, again, with different skilled people in their workforce. And then the fact that due to funding limitations, workforce challenges, and just the aging infrastructure itself, the constant reactive approaches that utilities are needing to take instead of a proactive approach where they can strategically plan, and also the impact that tends to have on ratepayers, where sometimes utilities have to abruptly increase their rates. That can have a negative impact on families and the cost of living in different areas. We'll get into this more in a second. What we developed in response to all of that, and what we're building on and sharing about more here today, is a single source of truth, or really a complete thought from when an inspection is intended and planned for, how an inspection is executed in the field, the data workflow process from getting that data from the field crew to in our case, a cloud environment to then be shared and reviewed by different stakeholders. But the process by which that data gets analyzed and assessed from a NASCO standpoint for the condition assessment, and now the ability to leverage the risk and rehab recommendation engine that we've built, and sharing those results with different stakeholders and executing projects from the platform and taking action. In addition to that, we've been able to provide professional services for our customers, whether that's on-site onboarding or on-site truck installs and training of our software, as well as different specialized projects for data migration and things we can do with folks that have large data sets that they'd like to convert, or programmatically making changes to it, converting it from maybe non-NASCO formats into NASCO formats. So to recap, one platform that's cloud-based and purpose-built for sewer and stormwater data management and asset planning. We have two separate types of AI or AI engines in the platform. One is our AutoCode computer vision AI-powered condition assessment process. The other, which we'll share with you shortly, is our risk and rehab large language models that we're using. And the fact that our platform is an always-on capital planning tool now. And the idea here is to enable the customer to experience zero downtime, as little downtime as possible, and the implementation happening as quickly as possible through training and through the ability to really affect positive organizational transformations here. So let's walk through a couple other aspects of the platform. Pioneer is the name of the cloud platform itself, right? This is our foundational data platform, and this is a way to structure and centralize all the inspection data, whether it's mainline pipe, lateral, manhole, as well as other data sources. It's cloud-based, it's secure. The info security that we have developed as far as the attestations are industry leading, specifically SOC 2 and ISO 27001. We're continually audited by third parties. Penetration testing is performed. The protocols we have for data sharing and privacy are audited by third parties, and that's maintained, and we take that very seriously. But the idea here is to eliminate bottlenecks, okay? Crews can return from the field at the end of the day, upload data, or if they are connected, through Wi-Fi out on the street, they can sync directly in near real time. And we have added a lot of different collaborative tools inside the platform to enable people to tag each other in comments, turning that into an automatic email notification with a link embedded in it to jump to a specific spot in a video. There's workflows that supports with respect to RFIs or change orders with contractors, or QC processes, pay items are approved or not approved, etc. Really seamless tools to enable people to execute large projects with multiple different sets of stakeholders, whether it be a civil engineering firm or different contractors and different folks internally at the utility as well, and ratepayers too. Probably one of the things that we're most known for, though, and I know the reason why we're called SewerAI, is our AutoCode tools. Okay, this is a computer vision AI set of tools where we have a number of different AI models that we've trained that can automatically identify conditions in a pipe from the video itself. Those outputs from the AI process are all reviewed by NASCO certified individuals to perform QC and entering ancillary data. So it's a turnkey process that's AI assisted that meets NASCO guidelines. And the idea here is that it improves the accuracy of the condition assessment, and it eliminates that inherent problem of different certified operators maybe having different levels of experience or different interpretations of the NASCO guidelines, and having a more consistent overall set of data. But also in the field, the crews can accomplish way more inspection footage, because now, instead of in the past having to constantly stop a $50,000 robot, take their hands off the controls, type information into the computer constantly each time they see a condition in the pipe, instead of having to do that, while they're parked on the street, while there's traffic control, and also importantly, while there's dewatering occurring from the remote maintenance hole with a $500,000 vac truck. Instead, that process can become much more efficient. And we have seen inspection crews double their productivity in the field. And also from a workforce standpoint, the operator, while still definitely being NASCO certified, doesn't have to be an expert on condition assessment. So you can take an employee and onboard them into your organization, have them be effective much sooner than what we've seen in the past, whereas usually those operators take about a year plus to really develop themselves to be consistent and efficient in doing it. So a lot more resiliency and flexibility amongst the workforce in terms of auto code. But also for the engineer that has to review that data, they can have a higher level of assurance about the consistency and accuracy of it, but also they don't have to watch the entire video anymore and second guess what they saw, et cetera. So freeing up the valuable time of a civil engineer is a huge focus of ours as of late. And I'll say one more thing about this, which is that, when we first started doing what we were doing, our vision was primarily based around this auto code professional service, not as much on data management. We found from our customers that there was a need for that. We built Pioneer in response to that. And now here in 2025, we really continued to listen to the feedback of our customers, whether it be small, medium-sized cities, engineering firms, contractors that perform find it, fix it type of projects, a need for a set of tools to help them make sound decisions on what to do with a pipe. Does it need to be fixed? Does it need to be replaced and upsized? If I'm going to fix it, can I do it trenchlessly? If I'm going to do it trenchlessly, do I need to reline the whole pipe, or could I do some point repairs? What type of method is best to address the condition of the pipe? Should I monitor the pipe, et cetera? So we built a platform that includes customizable risk recipes, based on the likelihood of failure of the asset and the consequence of failure for the asset. And it takes into account geospatial information from a GIS layer, and also, of course, the CCTV data itself and all of the PACP codes being leveraged, and also compared against aggregate data in our platform already. So there's a crowdsourcing event happening in our industry for the first time ever in our domain. And this provides for a level of transparency as well about how the recommendation got landed upon. And you can see that as a user in the platform, what exactly triggered that recommendation versus another one. And you can really drill in if you're interested in it, and the ability, as we'll show you, to interact with a large language model that is context aware and can help provide for additional enhanced amounts of insight, such as gallons per minute estimation for certain infiltration conditions and cost items very specific to the location of the segment, performing night work, having to do bypass, the prevailing wage of that specific area, things like that. We've made it context aware with bid tabulations, ASTM standards, NASCO guidelines, et cetera.
Eric?
Yeah.
Just a sec. Before we're going to go into the risk rabbit hole together, the risk and rehab, I do realize that just in surveying people, some people are new to SewerAI and Pioneer, and I appreciate that overview. I was just going to ask, before we go too deeply into risk, and I also acknowledge maybe everyone will hang out the whole time. We hope you do. Are there any questions about our core platform, about the data management platform, which we call Pioneer, or the AI coding, which we call AutoCode? We're sort of halfway through. I want to just see, are there any questions about that fundamental software that we built? Ask them now, or come talk to us after. Clear enough? Okay, just wanted to check. So if you want to know anything about what we've been doing for the last 5 years, Eric gave you a nice overview. We're now going to go into what we're launching today.
Yeah. In our go-to-market journey, one of the things that we have bumped up against multiple times at many utilities is sort of an expectation that they have that if they implement new software, it necessarily is going to take 6 to 12 to 18 months. It's a arduous process. It's difficult. It's expensive. And we really listened to what those factors were that made it that way in the past. And we put a lot of effort into creating a platform and a set of tools here that within a matter of days can be stood up by a new customer. Okay, these are email-based logins, but the input data that we're using for the risk and rehab recommendation specifically is twofold: a GIS layer and CCTV data. And the tool can be used without any CCTV data to help people prioritize where they should or where they might want to do inspections. But without the need for a high level of expertise on GIS or even CCTV either. You can take raw CCTV video, whether it's NASCO or not, and through AutoCode within 5 to 10 business days, have these types of outputs that you can leverage in your asset planning. Okay, so it's built for anyone to use. A fast way to get from raw data that's not structured and that's not associated or related to other data, getting in one place through the use of the AutoCode tools, very efficiently and consistently extracting where the defects are, where the features are in the pipe, taking that, running it through the various decision trees and rehab recommendation tools in the platform to then generate a specific list of actions that need to be taken for rehab planning and to execute those projects. Seth's now going to take over and provide a demo of this to all of us.
This is where we do our handoff. This is where I become your infomercial, your late night infomercial. So we're going to do something that I think is sometimes rare at these kind of events. I'm actually going to do a live demo of the product. We'll see how the WEFTEC internet is, but we want to show you the real product, not just screenshots, not just us talking at you. So I'm going to jump over to a browser tab. We didn't perhaps mention that our entire software runs in a web browser. It can be logged in from anywhere by anyone. We create easy email and password or single sign-in logons for your team. So this is in production on the web right now. It's a basic view of a risk and rehab map for a community based on CCTV data and GIS data, as Eric said. So what you're staring at should be fairly self-evident. Hopefully the screen is big enough. You've got color-coded, stoplight colored risk levels for the assets in this community. Currently, these are displayed by total risk, which is a combination of likelihood of failure and consequence of failure, and we can talk more technical details about that afterwards. I can very easily, however, change what's displayed on this map. I can display only the most recent NASCO likelihood of failure score. I can look at the assets by age. Basically, and this is an old set of pipes. Basically, anything that we're using to risk score can be changed to display how these assets score on the map. As I zoom into a neighborhood, maybe I see, oh, these assets over by the bay here are riskier. I can click on one of them, give it a second to load. So I've got some brief profile of that asset, what's going on with it. I can drill into it and get more information. So I can get a full profile of this asset, all the scoring, where it's located. Everything we've analyzed on consequence of failure is in the center of the screen here. Here, let me zoom my browser. So we've actually measured, again, you didn't have to do any work to get how close is this to a school, how close is this to a water body, which goes into the consequence of failure, right? If this pipe fails, are there young children affected? Is that overflow going to spill into the waterway? We've got all the GIS attributes, all the header values, and the inspection and maintenance history, right? So Eric spoke earlier about the ease of migrating data into our system. So we can have multiple inspections or cleanings stored and show that history, which is part of how we calculate the risk of this asset. I'm going to jump back to the map view now. I'm not going to get into all the details. You can obviously search by address. You can do some things we would all expect. You can change the map display to satellite view. Some of that fundamental stuff that makes sense. Again, this is all in a web browser. Someone doesn't have to be an ArcGIS Pro expert. They don't have to be working with local files. It's available to everyone in your organization. I want to show you also that we can filter down this data set. So it's possible to look, let's say, only at vitrified clay pipe in the system. If you're an engineering firm or a city worker who's doing some particular assessment of a certain neighborhood, pipes of certain ages, that can all be filtered on the map so you get exactly the view that you need. Now, Eric brought up earlier something that we heard from clients early on was, hey, I had a consulting engineer 3 years ago, this is a municipal client talking to me, make a very specific formula for how we calculate risk, or I did it myself, or I'm even the engineer, and it's in an Excel table somewhere, or a scratch pad somewhere, but I don't remember exactly what we did. And it's hard to replicate those calculations. I tweaked all those knobs to get the risk profile for my system I need. So Eric mentioned, we call that risk recipes. That's the language we're using. And so right now, there's a certain risk recipe being applied on this map, and I can easily change it. This is part of modern software, right? So I open this risk recipe panel, and I have a lot of choices. We'll get into it more later, but I actually have a choice about whether I use the artificial intelligence or a more traditional decision logic, decision tree, to output the recommendations for what to do about the pipe. But I've also got down here on these two tabs, hopefully you can see them, likelihood of failure and consequence of failure, where my mouse is there. Again, let me zoom in a little bit just to make it easier in the audience. So I've got all these likelihood of failure factors available to me. And it's not only the NASCO LOF, I've got the age and the depth of the pipe and the diameter and the length. I've even got this pretty unique thing called Pioneer Structural Benchmark. So this is where we're taking advantage of those 200 million lineal feet of pipe we have stored. And so if you've got an 8-inch VCP pipe in here, we're going to grade it on a 1 to 100 scale against every other piece of 8-inch VCP pipe our system is auto-coded. And again, you can use this risk factor or not, but we're going to say, is that better or worse than most of the 8-inch VCP we know about, where 50% is the middle?
Just want to touch on one other thing about that. We know a lot of utilities sometimes struggle with justifying or applying for grant funding or justifying budget money being allocated to the sewer stormwater repair. This is a way to objectively state where you rank against national benchmarks and averages based on the data that's in our platform.
So coming to the ease of use, though, you can easily modify this, right? So this is the default recipe, we call them again, we ship with, so that we give a 5 score as a factor to everything over 100 years old and a 4 score to everything over 75 years old. But if you want to tweak this recipe for your system, you literally just drag these sliders and click Save As, call it a recipe, WEFTEC Tuesday, and store that, and you can modify that at will, and the calculations update in real time behind us. You can do the same thing on the consequence of failure side. So I want to show you guys, again, out of the box, without anyone having to do any GIS geoprocessing, where you load a map layer for your community in, we calculate proximity to hospitals, proximity to schools, proximity to water bodies, diameter of the pipe. Recently, we pushed in the last few weeks all the road and railroad overlap. So what kind of surface is above this pipe? Where does it cross? As well as a broader land use calculation. Is it near an airport? Is it under a hospital? Does it run across a stream or a bus terminal? Again, you can add and remove factors here at will. You can also include or not include the factor altogether. All of that is easily modifiable. You press Save As, and you've got your own calculation. You can store as many of these as you want, and they're shared across your organization. So again, it's not on my private desktop that I've run a special calculation. Everyone in my org can see it and utilize it.
Yeah, and it's really one of the ways that utilities can bring engineers in so that they can use their expertise, applying it to the needs, circumstances of a specific utility as well, very easily.
Thanks. So we all know a map view is a nice way to get an overview of your system. I want to switch over to our table view. Again, giving you some highlights here of the capabilities. There's a lot more we could get into. If we set up a call with you, I'll take you through everything. This is the table view. It basically is all of that data spread out so you can look at it and analyze it. It's got every score we've applied to this asset to derive ultimately the total score. We really pride ourselves at SewerAI that your data is always yours, right? We store it, we stream it for you, but if you want to get this data out, you can easily pull it out of the system. So I'm going to show you, this is where it starts to get interesting. Let's say I switch recipes to use the one that's focused on a classic decision tree because I want to show you all how that works. And then I filter down to only things that the decision tree suggests possibly should be lining candidates. So now I went from 2,000 total assets to 85 potential lining candidates based on that data we've got. Again, I want to mention, you can easily pull that down to a CSV or a GeoJSON, which is an open source geodatabase file, if you want to do your own analysis on it. But we are trying to give our customers the tools to do it right here in the system, right? Now I've got a list of all these potential lining candidates, and maybe I want to go look at them. Well, I can easily click this last inspection date here, open the video. This is back to what Eric talked about. We've been doing for a half dozen years now, is giving people a place on the web to store and stream all their inspection data. So I can go watch this video. I can see right away this truly wasn't arbitrarily picked one for this demo, but there's a bunch of fractures here, a bunch of longitudinal fractures, a whole bunch of deposits. There's actually a broken. I can watch that video. I can use this URL to share it with anyone I need to. So I say, okay, that's a great lining candidate. I like that one as an option. What I can go ahead and do is select that asset, and I can tag it. And we've actually, I'll turn off revisit. I had already tagged that one. We ship with a bunch of pre-existing tags like capital planning, cleaning, inspection. Maybe I mark this for lining, and I save that. Again, as soon as I do that, now everyone else in my organization who might be using Pioneer can come in and use that tag to find the things that I've tagged for possible lining, making it really simple to do that information transfer. Now, a question you might be having is, how the heck do we arrive at the conclusion that this is a lining candidate? Obviously, we just looked at the video. But what I can do is click into this. So as I showed you right now, we're using sort of more classical decision logic. So it's telling me a couple things. Line this potentially because of the structural defects, but also I might want to clean this cautiously. There's deposits that need action, but my guess is there's already some surface damage on this, so we want to be careful about eroding the pipe further.
Due to the structural defects, you need to be careful that your cleaning doesn't exacerbate them, so there's a warning, clean with caution, not to make it worse.
So over here on the right, I've got a text-based explanation of how the decision logic arrived at that. I've also can open up a decision tree for those who are more used to flowcharts. You know, we know many softwares and many individuals have been doing this kind of stuff for years. Walks you through how it arrived at the conclusion that this is a potential lining candidate. Over here, how we arrived at the conclusion that there are deposits that need some careful cleaning. All that's available in the system. It's also available for customization. We have an engine behind this that allows us to very quickly, in a matter of 20 minutes, help you rebuild the decision tree you've already got. Many of you have decision logic you've been using for years. We can pull that in and make that available in the system.
We'll say more about this later, but this is one of the ways that we're partnering with engineering firms to enable them to have customized decision trees that the platform supports that are unique to that firm that they can use as needed, you know, further leveraging our tools.
And again, I want to emphasize that all this happens in near real time. So the minute you import that map, which Eric described, whether you've got CCTV data or don't have CCTV data, we're going to run this analysis and provide it to you. Your team loads in 10 more inspections tomorrow. The analysis is going to get run instantly on them. You don't have to wait for someone to have time in their day to go rerun the calculations. I'm going to clear out all the filters I've been applying here. Eric also mentioned that this can actually run on stuff that hasn't been inspected. And in fact, our team is working really hard right now on improving the model for predicting which assets should be highest attention. But you see in the center here, this is also something we introduced in the last few weeks, thanks to customer feedback, what says quick queries, right? And so these buttons are very common things that we heard people asking themselves. Can the system help me find fill in the blank? So we've got 7 of them right now, right? Do I want to find candidates for trenchless or point repairs? But maybe I click this inspect next button. What that's going to do is it's actually going to find me uninspected assets whose risk profile is higher in my system. Maybe because of their age, maybe because of their depth. Again, you think back to that recipe we built. So I've got 4 assets that the system is saying, you might want to inspect those soon, friend. And so I can go look at them, look at where they're located, figure out, oh, do I agree with that? Yeah, this asset is probably one that I want to get the team out to inspect. It's got a potentially high consequence of failure out near the water. It's old. Probably should get a team out to inspect that. All that's available on these quick queries. I think 1 or 2 more things I want to talk about are the AI recommendations, which I know a lot of you are probably interested in. And
Before you do that, I just want to point out one other thing because it's visible on screen. There is one recommendation output called consult an engineer. There is nuance to these things. There are times where that decision tree logic, can stop, and the platform will say, "Hey, as a professional engineer, should really look at this with their expertise and go further than that." So we are aware of those limitations, and maybe this doesn't need to be said, but this set of tools is not meant to replace a civil engineer. It's meant to get them to the 1 yard line so that they can do what they need to do more efficiently.
Thanks, Eric. So we got about 10 minutes left. I want to just go through the AI, and then we want to talk a little bit about what's coming next and how we can make this available to you all is really important. So you saw that I maybe some of you didn't see Eric was speaking, but I clicked on the quick query for lining candidates. Here's a lining candidate that the AI has surfaced that it needs a lining and an inspection. I'm going to click on that and show what that looks like. So as opposed to a decision tree, which is super consistent, but obviously limited in its nuance, Eric was describing this earlier. In this case, the large language model, we actually have several models running against each other and verifying each other, not against each other, but collaborating. It's describing why it reached a conclusion in longhand that this 15-inch VCP pipe probably needs lining. And it recommends that we rehabilitate the entire pipe using a trenchless method within the next 12 months. The AI is able to pull out from that inspection representative photographs and evidence of why it's reaching that conclusion. It describes the timing and the severity and also the AI confidence, right? For those of you who have become increasingly familiar with AI tools, a lot of this is based on confidence, right? What level of surety do we have that this is a good recommendation? It justifies it technically. It offers some engineering considerations that it needs a thorough cleaning before we line this thing. It also reviews alternatives. Why did it not recommend a spot repair? Why did it not recommend excavation or replacement? You'll see that there's some pre-suggested follow-up questions here. And I can ask that question, or I can actually type anything else. This is an interactive AI. And if you want to question it or suggest another method or ask about engineering details, you can do that. So I can ask, click this one, which rehab method, should it be spot repair or full lining, is recommended for this? What's the approximate cost per foot? It has some regional knowledge. We're working on that. Again, we've heard from customers and we always take feedback. There's a lot of regional variance in cost estimation. Many of you actually want to input your own cost tables. That's stuff we're working on right now. But again, it gives me in 10 seconds an explanation that you might need for a coworker or just for your own thought process about why CIPP is preferred, what it's likely to cost, and that you want to line the whole thing.
Yeah, you can also ask it, what's the cost of doing nothing? And it will spit out a narrative format about that in plain language.
I think that's probably good for the demo, Eric. I want to make sure we get to sort of what next.
Yeah. So just real quick, some of the early feedback that we've gotten from some of our early adopter customers. Danny Colvin from Sonoma Water. Some of you may have seen him recently on a webinar that we had. Risk and Rehab is changing the way that we assign our work and our assessments. Someone from the city of Warsaw, which we'll get into in a second, actually. A few years ago, I never would have dreamed that I would be making a motion for a company named SewerAI. Yes, what a time. This makes my job so much easier. It does. Someone in Mobile, Alabama. Steve Watson, Knoxville, Tennessee, Knoxville Utilities Board. SewerAI is our system of record for all of our inspection technologies. Warsaw next.
Yeah.
Let's look at a quick video, actually, from a city council meeting recently in Warsaw, Indiana.
SewerAI Corporation. The bulk of it you'll see is we will transfer all our videos where we have completely done sanitary and storm now. And then they run it through this AI program and grade that at PACP grading, which is what we use. So then we get that information back. We're able to better decide for next year what our lining projects are going to be, what areas need to be cleaned and retelevised. It's going to make that more efficient. We won't be going out and cleaning clean pipe. We'll be putting our resources towards problem areas. It also includes an asset management program within that. So it takes and then ranks your most serious asset problems that could potentially cause. And then you can click on that line at that point and it'll recommend the rehabilitation methods, and contractors in our area know when to do it. It's AI, it's interactive. You can ask questions and get responses from it. The big part of this is just having 100% graded. We have 100% of it videoed. Currently, we have maybe half of it actually graded. We don't have all the information we need to make better decisions, and this will give us that. Are there any questions on this?
Brian came to me a long time ago talking about the advantages of having this amount of coverage, the accuracy, and the dollars that will be saved by having it. The use of AI always concerns me, but absolutely incredible what this will do.
Yeah. The other advantage is it's all graded the same. So we have several people that are PACP certified and can grade it, but you may look at a crack. You can call it a crack, a fissure. So this will all be graded the same. Whether you agree with how it's graded or not, it'll all be consistent instead of having different people grade differently. So that's why we want to get even the pipe we've already graded put into this system so that it's all consistently the same.
Yeah, good point.
That's part of this is it's a tool to help us make better decisions and to rank that pipe on what we need to rehab next.
A few years ago, I never would have dreamed I was going to make a motion for SewerAI.
Basically, I think we should
Yeah.
simplify this. Do 30 seconds. But
Yeah, real quick, folks, on what's in our future roadmap. We are working on furthering the data visualization capabilities, adding more factors for consequence of failure, likelihood of failure. We know that's important. Also, more integrated cost estimates and the ability to customize different cost items. Again, those vary across different regions and markets. Relatedly, budgeting and project building tools directly in the platform, and further integrations with not just Trimble Unity Maintain, formerly known as CityWorks, but deepening our integration we have already with Cartograph. Infor IPS is another vendor that we've been working with as of late. AI inferred risk for non-inspected or not yet inspected pipes. We've touched on that already too. Adding maintenance holes and manholes as well to the risk and rehab recommendations. Seth already discussed a little bit about predictive maintenance, and I touched on this earlier, but importantly, we're finding a lot of traction amongst engineering firms, large and small, that are looking to leverage these tools and add their own expertise to have customization in the platform that they can offer their various clients, and other ways that we can help those smaller cities, especially with alongside an engineering firm as an implementation partner. If any folks here are interested in learning more about that, we'd be happy to talk through that with you at our booth too. And here we are at the end. Go ahead, yeah. We have a launch offer. So some of you folks may already know about this, but this is included in Pioneer's existing price cost structure, okay, for the first 12 months of a subscription. For current Pioneer utilities, we just turned it on and they get it, okay? That's another thing to be aware of when you do business with SewerAI. We're constantly improving and iterating on the platform, okay? And you'll experience those benefits as you use it. We don't have a modules-based pricing structure. New utility customers receive the first 12 months of the risk and rehab set of tools as well, at no additional cost. And for contractors and engineering firms, that is included with the auto code offering at no additional cost.
Oh.
So here we are at the end, actually the end. Our objective here is to provide the various stakeholders we've talked about with the level of collaboration that was not possible before, a higher degree of confidence in what they're doing and why they're doing it, and a level of control or transparency that we also think is very important especially as AI technologies continue to exist and be created, but to be implemented in responsible ways and to bring people in to the process so they can use them as much as possible themselves. And we'd really like to open it up for any questions that you folks might have, any yeah buts and how abouts and what ifs.
Thank you for joining us. Any questions from out there? Anything we can elaborate on? Certainly available afterwards, but don't be shy. Oh, I got one, yeah.
Sorry, I didn't catch the first half of your presentation, but did you talk about AI hallucination and any of that, how this affects or could it affect your models or any of your data sets?
We didn't get into those details. It's a great question. Yeah, I know everyone's concerned about that. One thing I did mention is in terms of the rehab recommendations, we actually have 2 different LLMs from 2 different sources checking each other to make sure that it doesn't go too far afield and, for instance, suggest a pipe rehab method that doesn't exist.
But in addition to that, as we showed, there's the ability very easily to toggle between the traditional decision tree logic and the LLM outputs. So while I suppose it's possible for there to be some level of inconsistency or question about an AI, generated response, a user can very easily toggle back to a traditional decision tree that they're aware of, that they may have designed themselves, to see what the difference is if there is one.
The other thing I'll just say is we're feeding the AI highly structured data, right? So that's one of the advantages of all this is that well-coded PACP data, that well-coded header data, all those GIS attributes are very structured, right? An 8-inch pipe is an 8-inch pipe, and an LLM is going to know that. And also at the same time, I'll just reiterate what Eric said, especially for the engineers in the room. I didn't get into all our tool tips, but all over the platform it says this AI recommendation, even this decision tree recommendation, does not replace the judgment of a certified professional engineer, right? And ultimately, the decision relies with a human expert to say what should be done about this pipe under the ground.
Yeah.
Thank you for the question. I think we're probably at time. Yeah, I got one more, and then we'll take questions afterwards too. We'll hang around.
So I think I'm very interested about how you calculate the likelihood of failure. Do you use the historical data, or you have forecasted the likelihood of failure using your machine learning algo?
Yeah, so there's 7 likelihood of failure factors right now that can be adjusted and weighted against each other inside the platform. So there's a PACP, existing likelihood of failure, that takes into account the major defects. There's the Pioneer structural benchmark. There's age of the pipe, length of the pipe, size of the pipe, and then the characteristics of the material of the pipe as well. And those can all be weighted. So that's the LOF output.
And right now, like that NASCO likelihood of failure is incredibly valuable, right? For pipes that haven't been inspected yet, I mentioned we're using some of those attributes. And actually, the next big project for our AI team is to work on that predictive degradation and figure out how we can, using all the published literature, better predict the likelihood of failure for a pipe that's uninspected.
Follow-up question, yes.
So in the future, do you mean that in the future you can apply this model to new unexpected instruments, but for now it doesn't apply to those?
We give it a score, but it's more linear at this point, I would say, based on very clear factors. Yeah, it's not as much based on the machine learning.
Mm-hmm. Yeah. We are out of time, folks. We really appreciate everybody who's been here for this. Thank you so much. Booth 7515 in the North Building, please, if you have questions and like to talk more.